Welcome to lesson 49. We do have a two-parter, but we're going to do both of those in one video because the second part is just like a minute. It's not very long at all. So 49a, the logarithmic function. So we know the two formats that we can recognize or we can derive a log from. The first one was when we have an answer that is equal to a base with an exponential power. So let's say 2 to the 2 squared would be 4. That's how we would do that. Well, we would write that in logarithmic format with the base here. 2 would be here. 4 would be here. So the log of the base 2 that gives us the answer 4, the exponent would be 2. So those are the two exponential formats. One's a log, one's a typical exponent that we understand have a relationship. There's that same relationship between n and l in both of these. In both of these, l is the exponent and n is the answer. So we can see that pretty straightforward. But as functions, they graph opposite of each other because one of them they flip their places. One becomes the independent function and one is the dependent function. We know the independent function is our x-axis when we graph a function, right? Because whatever we pick for x, it doesn't matter. We can choose whatever we want for x, and then we put it into our function and it spits out our y. And in this case, for this one, n is our y. That's our dependent. It depends on whatever we pick for x as to what the end result is, or our y point is. And so here I've got an exponential function graphed, and we know we have this little vertical or horizontal asymptote right here that just kind of peters off into nothing, and then this typically goes up, and this is with a positive exponential function. So here I have it graphed out. I have our little table, and then I have the table graphed out for us. I've picked L. L is our X. It's our independent. I've picked some values for L, and I've put them into the function, and they've given me my Y values. And you can see exactly how that works. 2 to the 0 is 1. And we know that 0, 1 point is typically always on our exponential function as the turning point of our graph. Now, whenever we want to graph a logarithmic function, however, it flips on us. And it doesn't truly flip so much as it flips and then it rotates 90 degrees. You can kind of see that if you were to flip this straight away, it would go more here, right? But it's opposite of one another. So here are the here's the table, and here are the results. When we flip the logarithmic function, and I did not put that down for you, this is going to be the log of 2n is equal to L, which is the same thing we have up here where our base is 2. So this is how you would graph a logarithmic function. You would make n the independent value. So you would pick whatever you wanted as the answer first, and then you would plug it into your logarithmic function. So in order to have the answer 1 from a base of 2, the exponent has to be a 0. Same thing here. In order to have an answer of 2 with a base of 2, the exponent has to be 1, right? In order to have an answer of 4 with a base of 2, the exponent has to be 2. In order to have a answer of 1/2 with a base of 2, the exponent has to be -1. And if you notice, just keep paying attention, everything here is here. Your n values remain exactly the same. Your L values that they're paired with remain exactly the same. It's just that they've switched places on the graph. Okay, so if you ever have a struggle with graphing it like this, with putting it into the function and solving it like this, rewrite it as its exponential form and then flip the answers. And that'll help you a lot with that if it gets confusing or you get stuck. So then you just graph them as if this were the x and this were the y, right? This is the x and this is the y. And then you get that function here, and then your asymptote is now down your negative y-axis as opposed to your negative x-axis. So you can see how they graph whenever they are, whenever they're graphed. They're either the same value, same values, but the logarithmic function just graphs opposite of the exponential function. So it's kind of neat to see that. That is all of lesson 49A. That's all we are talking about today, and that's all I want you to walk away with. So if you haven't written all of this down, then pause and do so now, because I'm about to go to 49B in the same video. All right, let's do 49B. So 49B, all we need to do is review our law of logs. Now, the book goes into a little bit more depth in regards to the law of the logs. Like, it gives a few examples in the text, but there are no example problems. So we just need to refresh our memories. Make sure you have this down somewhere, that when you are multiplying these two answers, when you have a log, that you can separate them out and add them together and you'll get the same answer. For a log that is a division or a quotient, you can separate it out and subtract it. The numerator, you subtract the denominator from the numerator. Remember, we likened this as taking it to the numerator and changing the sign to a negative. That's where that minus sign comes in, and it has to be applied to the denominator. Okay. And then the power rule is just when you have an answer with an exponent on it, we can take that exponent off and move it as a coefficient to the front of the log. So that is how we would convert that. So if you have it here, we can convert it here and get an answer, which helps us solve the problem. Or if we have it here, we can move it out to the front of the log, which can also help us solve the problem, just depending on how the problem is set up and what makes sense. All right, those are our 3 rules, and that is the end of lesson 49, and that's it. There are no example problems for either parts of this lesson. So just make sure you have your notes well in hand, put this down, and then I will see you in lesson 50.